But if you want to find the range, you take the highest value minus the lowest value, 35 minus 4. 35 minus 4, the range there is 31, okay? So that's how you find the range. But the range isn't always a great, measure to look at, okay? Sometimes it's not that descriptive, okay? So we can improve the measure of spread by looking at the spread of the middle half of the data, okay? Middle half of the data. So if you look at the middle half of your data, you get this thing that's called your IQR, okay? And that's your interquartile range. Now, when you're looking at these numbers and you're looking at this data, there's something that's called a 5-number summary. Okay, and some of you guys have had me in class before. We do this for test scores. So you have a minimum value, you have your first quartile, you have your median value, you have your third quartile, and then you have your max value. So when we look at this, okay, it's like taking your data and splitting it into quarters. Okay, a quarter between here, a quarter between here, a quarter here, and a quarter here. So this is the first quartile. This is technically your second quartile, but we have a special name for that. It's called the median. The third quartile and the maximum. Well, to find your IQR, we take our third quartile and we subtract our first quartile. And that gives us something, this measure that's called IQR. IQR goes with the median. They're together. Okay, we'll talk about that in a little bit. Okay, so how do we find these things? All right, well, it has to do with box plots. So I'm going to kind of do box plots together when I do this interquartile range, okay? Because they go together. So let's say I had a set of data, all right? So let's say I had 2, 5, 5, 6, 10, 12, 13, 15, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values, okay? And I want to find the minimum value, I want to find the first quartile, I want to find median, and I want to find third quartile, and I want to find the max. Well, min and max pretty easy. 2 and 17, gotta love that. Now, we said there was 9 values, so the fifth value would be your median. 1, 2, 3, 4, 5, there's my median. Now, to find your quartiles, what you do is you put an X through your median. Okay, and then you find the median of the first half of your data and the median of your second half of your data. There's more than one way to do this, but this is the accepted way to do it with AP Statistics. Why there's more than one way? Great question. I think it's one of the most ridiculous things I've ever seen. However, it is what it is. So I gotta find the median of the first half of my data. That's between 5 and 5. What number is between 5 and 5? Okay, and then I go here, it's going to be between 13 and 15, and that's going to be 14. So I have my 5-number summary. It helps describe about my data. I want to find IQR. Well, IQR is going to be this minus this. So 14 minus 5, and that's going to be 9. Okay? Now, the quartiles, okay, the quartiles and the median and the IQR, quartiles, median, and IQR are what's called resistant to outliers. Outliers don't make that much of a difference, okay? So see how it says 2, 5, 5, 6, 10, 12, 13, 15, 17. Let's say I didn't have 17. And let's say this was 30, okay? And I say, okay, how's it gonna change this data? Well, if I added them up, it would make a big difference with my mean. But guess what? This is going to stay the same. This is going to stay the same. Okay? So that's what it means when it says it's resistant. It's resistant to outliers. Okay? So, we've talked about all this stuff. Here's an alternate example. I apologize. For some reason, I didn't when I typed this up, or I had a student type this up, I missed the number 17. So add a 17 to that list, okay? Add a 17, and then I want you to find and interpret the IQR. You can pause the video. Okay, so let's see how many values. 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So let's, now this is an even amount of data, okay? An even amount of data. So I got to go between the 7th and the 8th. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. Then the median's going to be between there. Well, guess what? It's not on my list. That's okay. That's okay. The median of this, not including it, okay? The median of the first half of my data would be my first quartile. 1, 2, 3, 4, 5, 6, 7. So I pick the fourth value. 1, 2, 3, 4. So I've got 10 for my first quartile. And then I pick 1, 2, 3, 4, 5, 6, 7. Pick the fourth one. 1, 2, 3, 4, 17. So it looks like 7 is my IQR. However, we need to know what it is. 7 what? It's 7 grams. Okay, 7 grams. And the other thing that we have to talk about there is it says interpret. You're going to see that over and over and over and over again. Okay? And we have to interpret that. So we would say something like the middle 50%, okay, because that's what a quartile is. This is the 25th first quartile, 25th, 75th, okay? So the middle 50%, okay? The middle 50% of amounts of fat for, what is this about? What is this, chicken sandwiches? For McDonald's chicken sandwiches is 7 grams. Okay, that is how you interpret. Can't forget that. You just have 7 grams, you can't get full credit. You get half wrong, and that's criminal. Find and interpret. You have to make sure that you interpret as well. Okay? You just check my notes and see if I'm going to pause here, or what am I going to do? I guess we'll keep hammering through, and we'll get to, yeah, let's see. Because I'm going to have to do this in 2 parts, probably. So, I guess at this point, let me just look through and see what I want you guys to do. I think at this point, what I'd like you to do is to do the check your understanding on page 55, and that's numbers 1 through 4. Okay? And then, let me see if I can give you another check your understanding. That might be it for right now. Yeah, let's hold off on 1 second. Let's push forward a little bit. Okay, so we're going to hang on to this thought. Okay, we're going to do how to identify outliers, and then making a box plot, which we've almost done already, and then I'll have you do the 2 check your understanding. So we're going to hold off on that thought for right now. Okay, so what we want to do is we want to talk about how do you identify outliers. And there's a rule, and it's 1.5 times the IQR. Okay, and that's the rule for outliers. And if any values fall above the 3rd quartile, okay, plus this number, plus 1.5 times the IQR, or they fall below the 1st quartile minus 1.5 times the IQR, then those values are considered to be called outliers because they would fall outside the normal pattern of points. Okay? So what you want to do, and it's right on the other page here. Okay, I got it right here. Okay, it talks about it right here. So what you want to think of is, we're going to think of a box plot right now, okay? 'Cause we're going to get to this. Why they don't do it in this order, I don't know, but when you're standing here and you're on your third quartile and you go out 1.5 times your IQR, it's like you have a fishing net. And your fishing net, let me make that box plot bigger. You're standing on this thing and you have this fishing net. Here's your fishing net, okay, 1.5 times the IQR, and you're reaching out and you're reaching out, and anything beyond where that fishing net will go would be considered an outlier. And you stand on this first quartile and you reach out and try to see how far out you have to go there. And anything beyond that is considered an outlier. Okay? So, all right, so here we go. Here's the 14 amount. I think I have 14 now. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we did do this correctly. So I'm going to do this example with you. And then you'll be able to do the check your understanding, okay? So we want to see if there's any outliers here. We want to test for outliers, okay? So what was our IQR when we did this? Our IQR was 7, okay? And our first quartile was, oh wait, no, we didn't do this one. We didn't do the chicken sandwich. I think I did it on a different example. All right, so let's do this one. So we have 14, right? So we're going to go to the middle, 1, 2, 3, 4, 5, 6, 7, 8. So we know that the median is right in there. And so we go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. I think we did this somewhere. I don't know, maybe it's on the other page. And then do the same thing over here, 1, 2, 3, 4. Okay, so those are my quartiles. That's my first quartile. This is my third quartile. So when I did that, we did this a few minutes ago, 17 minus 10, I got 7. So I stand at this thing here, I stand at 17, and I reach out with that net, and that net is 7. Okay, well, it's really not 7, is it? It's gonna be 1.5 times 7, okay? So I go to my calculator and I type in 1.5 times 7, and I get 10.5. So that's what I'm reaching out with. I'm reaching out with that 10.5. And I gotta reach out over here with the 10.5. So if I take my first quartile, which is 10, and I subtract the 1.5 times the IQR, I get negative 0.5. Well, that tells me there's no low outliers. Okay, because the lowest value is a 9. Now let's take that 17 and add 10.5, and I get 27.5. So if I get 27.5, but I have a value 28, which is bigger than that 27.5, it's bigger than the third quartile plus 1.5 times the IQR, then that tells me that that number is an outlier. And that's how you go and calculate outliers, okay? So we are going to finish up here with the box plots. We are going to finish, okay? And when we're doing these box plots, we have a 5-number summary, okay? And we already talked about that. The 5-number summary is here. The minimum, the first quartile, the median, the third quartile, the maximum, okay? That's this, here it is, smallest value, first quartile, median, third quartile, highest. 25% of the values are there, 25% of the values are there, 25% of the values there, and 25% of the values are there. So the way that we do this, and I'm going to use this as an example here, okay? The 2, 5, 10, 14, 17. The first thing that you have to do, okay? The first thing that you have to do is you have to make yourself a number line. And you look at your data. My data starts at 2, and it ends at, I'm not going to make 30 because it's going to make my number line a pain, okay? So I will do, actually, you know what? We'll do 30, okay? So I got to go from 2 to 30. Well, I don't want to go 1, 2, 3, 4 because that's going to be a pain to do. I'll just go by 2s. So it's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. So there's my number line. Notice, I make the number line first. You have to make the number line first. And now for these 5 numbers that we had in our 5-number summary, we put a dot or a dash. So the minimum is 2. I'm going to put a dot there, or a dash. 5. Well, 5 would be here. And then 10, the median is here. And then 14 is here. And then my max here is 7, but remember we changed that to 30. So I'm going to make that a 30. And my last one is way out there. Okay, so this is going to be interesting. I want to show this to you. So, do I want to use 30? I don't know. I think I'm just going to use 17 for now, okay? So let's use 17. It's gonna warp our data. So we're going to disregard that. I'm going to make a little dash at 17, okay? So we make a box around the center 3 values. So kind of like your IQR, the box goes, and then this is a whisker, and this is a whisker. And there is your box plot. Okay, that's how to make a box plot. So let's say our list looked a little different than this. Okay, let's say that our list looked like this. So let me go 5 and 12 and 13 and 15 and 19 and 20 and 21 and 46. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. Even amount of values. This is good. This is good for us to practice. So our median is going to be between, what do you say? 1, 2, 3, 4, 5, 6, 7, 8. Between the 4th and 5th. 1, 2, 3, 4, 5. So my median comes in there. Okay. So my min is 5. My first quartile I'm going to find in a minute. My median, my third quartile, and my max. So let's look. Okay, well my min's 5. My median's between 15 and 19, so my median's going to be 17. Okay, and first quartile, the middle of these. Well, that looks like it's going to be 12 and a half. And then the middle of these, and that's going to be 20 and a half. And then my maximum value is 46. So I'm going to make what's called parallel box plot. Parallel box plot. So I'm going to graph this on that same scale. Now I'm going to have to add to my scale here. I got 30, 32, 34, 36, 38, 40, 42, 44, and 46. They look very different. My minimum value is still 5, or now is 5. First quartile, 12.5. So I go to where I think 12.5 is. I don't know if it's exact. I'm not going to be checking that. 17 is here. 20.5, here's 20. 20 and a half is going to be a little bit further. Now, when I go to draw my box plot, if you have outliers, okay, if you have outliers, then your box plot will extend to the point that's not going to be an outlier. It doesn't go all the way to the end. 46, can we agree 46 would be an outlier? I'm going to show it to you in a minute. But this would not go all the way out there. Your box plot would look something like this, done correctly. So that shows that you have outliers. I'm going to show you how to do it in your calculator in a minute. You'll never have to do these by hand. Okay, you'll never have to do these by hand. So let's find out what our outliers are. So I go 20.5 minus 12.5. Third Q minus first Q gives me my IQR. And that's going to be 8. I take 8 and I multiply by 1.5. 8 times 1.5. And I get 12. So that's what I use. And I add 12 to 20.5. Well, that tells me that that's going to be 32.5. So anything bigger than 32.5 is an outlier. Outlier. And then I go 17 minus 12. That's 5. It's not beyond that. So it's not going to be, I'm not going to have a low outlier. Okay? Because it's not beyond that. So when I make my box plot, the whisker will extend to the biggest number that's not an outlier. So it goes to 21. So that would be here. And then I go way down here at 46 and I put a dot. So the way that we do that, the way that you will do that right now, I'm going to tell you how to do it. And when we have examples like this in class, don't do it by hand. do it with a calculator. So we have our calculator, and I'm going to do a statistical plot. So I go to second stat plot I'm going to go down here, and now here's a histogram. That's what we used before.